Hi everybody, in this video I'm going to be solving this quite tricky relative velocity problem. Let's have a look at it. A cyclist travels at 15 kilometers an hour on a road heading east. When she is traveling in this direction, the wind appears, I'm going to highlight that word there, the wind appears to be coming from a direction of 60 degrees east of north. When she turns around and travels west on the road at the same speed, the wind appears, again, to come from 60 degrees west of north. Find the true speed and direction of the wind. Okay, so we've got two situations here that we're given. The first situation is when the cyclist is travelling 15 kilometres an hour on a road heading east. Okay, let's write down what her velocity here is in this situation. Her velocity, write a cyclist there, velocity of the cyclist in the first situation, well, she's going 15 kilometres an hour on a road heading east. Okay, east is that direction, that's the I direction, so she's going 15I and 0 in the J direction. Okay, at that time, when she is travelling in this direction, the wind appears. Now, I told you to highlight that word because it appears to the cyclist. So this is the velocity of the wind relative to the cyclist. So the velocity of the wind relative to the cyclist, well, it is coming from a direction of 60 degrees east of north. Well, 60 degrees east of north, that's that 60 there. And it's coming from that direction means that it's actually heading in this direction here. So if that's 60, that's 30, this one's 30 here. So we're wanting to get a vector that's going this way. Well, it's going to be, how would we do this? Well, we're thinking about this whole angle there, 180 plus 30. That's going to be an angle of 210 degrees. Remember, we always actually want the angle from the positive x-axis. So that's all around there. Now I could just pop that in my calculator to find what that is, but you might know your exact values and you know that that is going to be 1 to root 3. So here for this vector, we've got negative root 3 on 2I minus 1 over 2j. So that's what that is, but we're not told what the how fast she finds the wind going. So I'm going to say that the speed of the wind is, and let's just make up a letter, let's say it's m kilometres per hour. So the velocity of the wind relative to the cyclist, I'm going to put my negative root 3 on 2 and my negative 1/2 there, and then multiply both of those by m. Okay, so that's what I've got in the first situation. And I could write a little formula there. Well, I know that the velocity of A relative to Earth equals velocity of A relative to B plus the velocity of B relative to Earth. Okay, in this case that I'm going to say that the cyclist is B and the wind is A. And I'm saying that because I want A relative to Earth. Find the true speed and direction of the wind. That's the wind is what I'm looking for, the velocity of the wind. So the wind relative to Earth. So that is A relative to B. So the wind relative to Earth is going to equal the velocity of A, the wind relative to B, the cyclist, which is going to equal this one here, negative root 3 on 2m, negative 1/2 of m, plus velocity of B relative to Earth. That's what our cyclist is doing, 15, 0. Okay, so that's the first situation. But now I'm told that when she turns around and travels west on the road at the same speed, the wind appears to come from 60 degrees west of north. So we've got a different situation here. I'm going to write this down. This is the blue situation. The velocity of the cyclist this time is, well, she's traveling west, so her vector is negative 15, 0. And the wind, well, what's it doing? The wind appears to be coming from 60 degrees west of north. Well, it's coming from, if that's 60 in there, that's 30. It's coming from there, which means it's heading down this way here, and it's going to be that way there, an angle of 330 degrees or negative 30 degrees here. Now I could use my calculator for that to work out that ratio, or I could just know that triangle. So the velocity of the wind in this situation, velocity of the wind, and this is the wind, again it's relative to the cyclist. The I component is the cos of negative 30, which is root 3 on 2, and this one here is negative 1/2, the sine of negative 30 degrees. Now, I don't know how fast that wind is actually going, so I'm going to call it, this time I'm going to call it N. I called it M kilometers per hour last time, it's N kilometers per hour this time. Next thing I'm going to do is make another little equation of the wind relative to Earth. The wind relative to Earth is equal to the wind relative to the cyclist, which is root 3 N on 2, and then negative 1/2 of N, plus, and then our cyclist relative to Earth, which this time is negative 15, 0. Now, do you see what I've got here? I've got the wind relative to Earth, which is equal to this, and I've got the wind relative to Earth is equal to this. Now, if the wind relative to Earth is worth this, is equal to this, and it's also equal to this, well, then that blue box is equal to the green box, isn't it? And I can equate those. So how do I do it? I'm going to say negative root 3 over 2m plus 15. I've just combined these two terms. That's the I component. Negative 1/2 of m plus 0 must be equal to this box here. Root 3n on 2 minus 1/2 of n, and then that one there is minus 15. Okay, vector equality. I equate the i's and I equate the j's. I'm going to start with the j's because they look simpler. I've got negative 1/2 of m equals negative 1/2 of n. I'm going to times both sides by negative 2. And I find straight away that m is equal to n. That means the speed of the wind is the same for both situations. Now, I can use that fact here when I'm equating my I values. I've got negative root 3m over 2 plus 15 is negative root 3n over 2 minus 15. Now, I know that n is equal to m. So I'm just going to change that one there straight away to m. So it's the same on both. Well, I've got, can collect terms now, collect like terms. So I've got negative 15, 15 there, negative 15 there. Bring that one over, that will make 30. And I'm going to bring this negative over here. So it's root 3m on 2 plus another root 3m on 2. Root 3m on 2, I've got two of them now. Cancel those. I've got 30 is equal to root 3m. I can find out what m is here. M is 30 over root 3. Now I could put that in decimals, which gives me 17.32 for m. Now I would like to find the true speed and direction of the wind. Well, to do that, this one here, the wind relative to Earth, is the true speed and direction of the wind, and I can just use this equation here for that. So the true speed and direction of the wind, true wind velocity, let's call it that, is equal to negative root 3 on 2 m plus 15 and negative 1/2 of m. I know what m is. m is 17.32, so I'm just going to substitute that in. So that will give me 0I minus 8.66j as the true velocity of the wind. Well, let's draw what that looks like. 0I minus 8.66j. That means the wind is heading south. So the wind is heading south. If it's heading south, where's it coming from? If it's heading south, it's coming from the north. And what is the magnitude of that? At 8.66 kilometres per hour. Okay, I hope that was helpful. If you'd like me to do some more of those, I can.